Here's the conditional statement, if P, then Q, introduced in the previous lesson. And let's do an actual definition written in the if-then form. If an angle is a right angle, then it has a measure of 90 degrees. And now let's introduce something new, not P, or the negation of P, shown by the symbol on the left. Or in this case, the negation of P is an angle is not a right angle, and the negation of Q is an angle does not have a measure of 90 degrees. So here's our statement. If P, then Q. The converse we already know from the previous lesson. If Q, then P. Here's a new one. The inverse. If not P, then not Q. And the contrapositive. If not Q, then not P. Notice the contrapositive is the converse of the inverse. Now let's look at these four concepts for our definition for a right angle. Our statement is, if an angle is a right angle, then it has a measure of 90 degrees. The converse we already know. If an angle has a measure of 90 degrees, then it is a right angle. And now the inverse. If an angle is not a right angle, then it does not have a measure of 90 degrees. And finally, the contrapositive. If an angle does not have a measure of 90 degrees, then it is not a right angle. Well, of course, this is a definition. All four of these are true statements. The original statement, the converse, the inverse, and the contrapositive, all true. Well, now let's look at our first theorem. If two angles are right angles, then they are congruent. That's true. Now let's look at the converse of our first theorem. If two angles are congruent, then they are right angles. That's false. And now, the inverse of our statement, if two angles are not right angles, then they are not congruent. Also false. And if two angles are not congruent, then they are not both right angles. And that's true. And now let's look at a brand new one. If you live in Chicago, then you live in Illinois. That's true. If you live in Illinois, then you live in Chicago. The converse is false. If you do not live in Chicago, then you do not live in Illinois. We know that to be false. You can live outside of Chicago, but still be in Illinois, so that statement is false. But let's look at the contrapositive. If you do not live in Illinois, then you do not live in Chicago. The contrapositive is true. Now let's look at a statement that we know to be false. If you live in Illinois, then you live in Chicago. The converse of this false statement, if you live in Chicago, then you live in Illinois, that happens to be true. And the inverse, if you do not live in Illinois, then you do not live in Chicago. That's true. The contrapositive of our false statement, though, if you do not live in Chicago, then you do not live in Illinois. That's false. Notice in our last three cases, the statement and the contrapositive have always agreed. If the statement is false, the contrapositive is false. The converse and the inverse have always agreed. If the converse was true, the inverse was true, and vice versa. Well, let's do one where everything is false. If you live in Indiana, then you live in Chicago. Of course not. If you live in Chicago, then you live in Indiana. The converse, also false. If you do not live in Indiana, then you do not live in Chicago. Well, that's false. And if you do not live in Chicago, then you do not live in Indiana. And that's also false. So we've done a definition where all four of these were true. We've done a false statement where the statement was false, the contrapositive were false, but the converse and the inverse were true. And we did a theorem where the statement was true, the converse was false, the inverse was false, and the contrapositive was true. In all four of our examples, though, the statement and the contrapositive have agreed, either both true or both false, and the converse and the inverse have agreed, either both true or both false. And that brings us to Theorem 3. If a conditional statement is true, then the contrapositive of the statement is also true. If P, then Q, if and only if not P, then not Q. And our new double-arrowed symbol means if and only if. And IFF also means if and only if. Theorems can be proved, and in this series of lessons, I will show proofs for most of the theorems, but I submit Theorem 3 without a formal proof. Now let's look at circle diagrams, Venn diagrams, and Euler diagrams. Well, one geometry textbook I have calls circle diagrams Venn diagrams, and the other calls them Euler diagrams. So I went to Wikipedia. Wikipedia assured me that Venn diagrams and Euler diagrams were related when used in statements of logic. So we start with a circle, and this circle represents people who live in Chicago. And the next circle represents people who live in Illinois. It's a bigger circle because Chicago is contained wholly within Illinois. And now we know that if you're mayor of Chicago, you're required to live in the city. So we know that the mayor of Chicago should be in Circle A. The mayor of Chicago lives in Chicago. And here's the narrator. He works in Chicago, but he's not required to live in Chicago just because he works there, and he doesn't. He lives just outside the city limits. He lives in Illinois, but he does not live in Chicago. Well, now let's expand. Circle A represents people who live in Chicago. Circle B, people who live in Illinois. Circle C represents people who live in the United States. And finally, Circle D represents people who live in North America. Chains of reasoning. If P, then Q, and if Q, then R, then if P, then R. Has some similarities with the transitive property of equality, which says if A is equal to B and B is equal to C, then A is equal to C. Well, that applies to the statements we just looked at. If you live in Chicago, then you live in Illinois. If you live in Illinois, then you live in the United States. And that implies this conclusion: if you live in Chicago, then you live in the United States. And we can even take it one more step. If P, then Q, if Q, then R, and if R, then S, then if P, then S. And an example: if you live in Chicago, then you live in Illinois. If you live in Illinois, then you live in the United States. If you live in the United States, then you live in North America. Our conclusion is, if you live in Chicago, then you live in North America. Here's a series of statements. None of them are necessarily true, but if you accept them as true, you'll get to make a conclusion, and let's see what it is. If I study for many hours, I will do well in geometry. Sadly, many students study for many hours, and they still have difficulties. If I do well in geometry, I will get into a good college. Once again, it is my belief that there have been students that have done very well in geometry, and for one reason or another, they did not get into what they might have defined as a good college. If I get into a good college, I will be able to get a high-paying job. Perhaps, but I don't know if that's necessarily true. And finally, if I get a high-paying job, I will become wealthy. And once again, I believe people can get high-paying jobs, not manage their money well, and still not become wealthy. However, if you accept all four of these statements is true, I hope you can make the conclusion, and I'll give you a moment to make it, and here it is. If I study for many hours, I will become wealthy. Here's the conditional statement: if P, then Q. Its converse is, if Q, then P. Its inverse is, if not P, then not Q. And finally, the contrapositive is, if not Q, then not P. Circle diagrams, also known as Venn or Euler diagrams, help us depict conditional statements. That symbol with the double arrow means if and only if. And Theorem 3, if a conditional statement is true, then the contrapositive of the statement is also true. If P, then Q, if and only if not P, then not Q.